This is SpaceTime Series 24, Episode 130. Coming up on SpaceTime, mystery signals from the galactic center, another asteroid's close flyby of the Earth, and NASA delays its maiden flight of the Artemis 1 mission until next year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered mysterious signals coming from the direction of the galactic center of the Milky Way. The unusual radio waves reported in the Astrophysical Journal fit no currently understood pattern of variable radio sources and could suggest a new class of stellar object. The study's lead author, Zhaiteng Wang from the University of Sydney, says the strangest property of the new signal is that it has a very high polarization. It oscillates in only one direction, but that direction rotates with time. The brightness of the object also varies dramatically by a factor of 100, and the signal switches on and off, apparently at random. Wang says he's never seen anything like this before. Many types of stars, including pulsars, supernovae, flaring stars, and fast radio bursts, emit variable light across the electromagnetic spectrum. Wang and colleagues made the discovery while searching the sky as part of VAST, the Variables and Slow Transient Survey, using the CSIRO's ASCAP, the Australian Square Kilometre Array Pathfinder radio telescope in outback Western Australia. ASCAP's 36 parabolic dishes survey the sky in low frequencies. The signal, catalogued as ASCAP J173608.2-321635, started out as invisible, became bright, faded away, and then reappeared. It was intermittent for roughly 15 minutes every few weeks. At first, the authors thought it could have been a pulsar, a spinning neutron star, or alternatively possibly a flare star, a main sequence star, usually a red dwarf, emitting bright stellar flares. But the signals from this new source simply didn't match what astronomers would expect from these types of stellar objects. But the mystery deepens, because after detecting 6 radio signals from the source over 9 months in 2020, astronomers tried to find the object in optical wavelengths, but found nothing. And follow-up observations using the Parkes radio telescope in central western New South Wales also failed to detect the strange signal. So the authors then turned to ASCAP's counterpart in South Africa, Meerkat. It covers the skies in mid-frequencies. And luckily the signal returned, but the behaviour was dramatically different. The source disappeared in a single day, even though it had lasted for weeks in the previous ASCAP observations. Interestingly, these observations do have some parallels with another emerging class of mysterious objects, a group known as Galactic Center Radio Transients, including one dubbed the Cosmic Burper. But while this new object does share some properties with these, there are also differences, and Wang points out that astronomers really don't understand what those sources are anyway. So it all just adds to the mystery.
It is a highly variable and highly polarized source near the galactic center. So what is a variable? The variable is something like is turning on and off in the brightness. And what is polarized? It is something our human eyes cannot distinguish. However, ASCAP can see something like that. That means the electromagnetic field of the signal just rotates when it goes through the universe.
I take it you've ruled out that this is a pulsar already. Could it be a pulsar in a binary system?
Well, actually we have did some analysis for this kind of scenario, but unfortunately, we didn't see any evidence for this kind of thing.
So this transient radio source remains a mystery for now.
Right, yeah.
How did you find it?
So we use ASCAP, and there is a survey called VAST, which is a variable and slow transient survey. So the purpose, the goal for this search is use the ASCAP to find the source that's turning on and off. So our original search is just to find a source that are variable. And we can check for the polarization. And after we pick up several variables, we found this source is also circular polarized. So we think it is an interesting source.
So you found it with ASCAP. You then had a look for it with the Parkes radio telescope, and that didn't do much good. But Meerkat managed to find it again.
Right, yeah. So Parkes telescope is like it is used for finding polarization, like finding any polar pattern. But we don't know if the source was actually on during our Parkes observation. So a non-polarization detection doesn't mean so much. So what we do for Meerkat is that we use the Meerkat telescope to do the imaging and polar searching at the same time. So that means if we detect the source in the imaging domain, we can perform the polar search, and then after 3 months of reading, we finally get a detection. However, we still cannot find any polarization within that piece of data.
I guess you're looking forward to the square kilometre array coming online as a possible means of solving this puzzle.
Right, yeah. Also, I think SKA is a good instrument for finding more, no matter these kind of sources or even the new kind of sources. It is a very tremendous instrument in the future.
There are a lot of galactic center radio transients out there, but they're a mystery too. We really don't know what's causing them.
Right, yeah. Also, this signal shares some similarity as the galactic center radio transients, but as you said, the GCRTs are still a mystery. So it would be interesting to do any further analysis, no matter for GCRT or this signal.
So you've only looked for it in radio. The other thing that shines well from the galactic center is infrared. Have you had a chance to look for it that way?
Right, yeah. So there is a possible interpretation for variable and circular polarized radio source is that it could be a star. So the most straightforward way for us to confirm a stellar origin is that to perform a infrared observation. But unfortunately, we still, we get the tactile time, but we didn't see anything.
All right. So that rules that one out.
Yeah, so that is why it is a mystery. So all possible interpretations cannot explain the phenomena or properties for this signal.
That's Zaiting Wang from the University of Sydney. And this is SpaceTime. Still to come. Another asteroid undertakes a close flyby of the Earth, and it was supposed to launch next month, but NASA has now delayed the maiden flight of the Artemis 1 mission until next year. All that and more still to come on SpaceTime. An asteroid the size of a refrigerator has just zoomed past the Earth at an altitude of just 3,000 kilometres. That's lower than many satellites. The 2-metre-wide space rock, named 2021-UA1, made its closest approach above Antarctica. Now, the scary part of this story is that scientists were totally unaware of the object until 4 hours after it had passed by the Earth. See, that's because it approached Earth from the direction of the Sun, and so it was hidden by the Sun's glare. Meanwhile, a much larger asteroid, some 330 metres wide, will come within the Earth's neighbourhood next month. Classified as a potentially hazardous asteroid because its orbit frequently brings it close to Earth, 1982 DB will pass 3.9 million kilometres from the Earth on December the 11th, travelling at more than 6.5 kilometres per second. At least we know this one's on the way. This is SpaceTime. Still to come. NASA says it's now targeting February next year for the maiden flight of its new SLS Moon rocket and Orion crew capsule. And NASA launches 4 new crew members to the International Space Station as 4 others return home splashing down in the Gulf of Mexico. All that and more still to come on SpaceTime. NASA says it's now targeting February next year for the maiden flight of its new SLS Moon rocket and Orion crew capsule. The Artemis 1 mission was to launch from the Cape Canaveral Space Force base in Florida next month. The mission will be an unmanned test flight around the Moon, lasting 4 to 6 weeks. The giant 98-metre tall SLS, or Space Launch System rocket, has now been fully stacked at the Kennedy Space Centre's massive vehicle assembly building. That's the same building which used to put together the Space Shuttle and before that the Saturn V Apollo moon rockets, predecessors to the SLS. Now, if current assembly tests go well, the mega rocket will roll out onto Space Launch Complex 39B on its giant crawler transporter in January. It'll then undergo what NASA refer to as a wet dress rehearsal. NASA mission managers say the new February launch window opens on the 12th and runs through until the 27th. After that, the next launch windows won't open until March and then April. As well as testing the SLS Moon rocket and the Orion crew capsule, the flight will also deploy a number of CubeSats, which will test new technologies and undertake scientific experiments. If the SLS launch vehicle and Orion crew capsule form nominally on the Artemis 1 mission, a manned mission around the Moon, Artemis 2, will now likely take place in 2024. It was originally scheduled for 2023. And that will be followed in 2025 by the Artemis 3 mission, returning humans to the lunar surface for the first time since the Apollo 17 mission in 1972. Artemis 3 would see 4 astronauts fly to what's called the Gateway space station. Gateway is yet to be built and will be placed in orbit roughly between the Earth and the Moon. So as the Moon orbits around the Earth, Gateway will follow it around, but always keep the Earth on one side and the Moon on the other. It would then be used as a staging post for 2 astronauts who would travel to the lunar surface, landing near the lunar South Pole for an extended stay which could last several days. The Artemis 3 mission's been delayed by a year due to government budget cuts. That's impacted the development of the new spacesuits needed for EVAs, or extravehicular activities, on the lunar surface. EVAs on the Moon's surface during the Apollo era showed that lunar dust, while as fine as talcum powder, was as sharp as broken glass, and it was seriously damaging the material from which the existing spacesuits were made. And that same basic design from the Apollo era is still used today by crews aboard the International Space Station. And while fine for a spacewalk, they wouldn't stand up well to extended time on the lunar surface. This is SpaceTime. Still to come, NASA launches 4 new crew members to the International Space Station as 4 others return home. And later in the science report, a new study shows that smoking and drinking booze is likely to increase your risk of age-related macular degeneration. All that and more still to come on SpaceTime. SpaceX's 3rd operational crew transfer mission has successfully docked to the forward port aboard the International Space Station's Harmony module. The Dragon capsule, carrying 4 Expedition 66-67 crew members, had launched 21 hours earlier aboard a Falcon 9 rocket from Space Launch Complex 39A at the Kennedy Space Center at the Cape Canaveral Space Force Base in Florida. NASA says the mission was historic as it included the 600th person to fly to space. The launch had been delayed several days by bad weather, as well as an unspecified medical issue involving one of the crew. And before you ask, we're told it wasn't COVID.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Copy 1 Alpha. Laboratory in orbit. The International Space Station. Vehicle is pitching downrange.
Stage 1, propulsion is nominal.
And that's the call we want to hear. Good performance on that first stage so far.
T plus 30 seconds. Falcon 9 powered by 9 Merlin 1Gs. Pushing Dragon into low Earth orbit on the way to the International Space Station.
Power and telemetry nominal. Stage 1 throttle down.
And we're into the throttle bucket in preparation for max Q. Getting ready to throttle the engines back up.
Stage 1 throttle up. Max Q.
Stage 1 Bravo.
Copy 1 Bravo.
That 1 Bravo call is for the second stage abort mode on the first stage. That is going to take them through the first stage, burning just before the second stage activates off the coast of North Carolina. That next milestone coming up shortly will be MVAC.
MVAC chill underway.
There's the call out. We're getting the second stage engine turbo pumps ready for their ignition coming up in just a little more than 40 seconds. We've got the major vents coming up here shortly. We're going to get main engine cutoff at 2 minutes 36 seconds. The stages will separate. Then the second stage will ignite, carrying Dragon on its way into low Earth orbit. Continues to look good.
Stage 1 throttle down.
Stage 1 throttling down at 3.5 Gs. Getting ready for MECO.
MECO. Stage separation.
Stage 2 Alpha.
Copy, 2 Alpha.
All right, we have ignition of the second stage. And Crew 3 is now on their way to the International Space Station.
First stage. Currently waiting for the call out from the SpaceX propulsion responsible engineer that the 3 Merlin 1D engines have lit to begin slowing down the first stage prior to entering the Earth's atmosphere.
Stage 2 FTS is safe. Stage 1 entry burn is in startup.
We've heard stage 1 entry burn is startup. We've lit the center engine. We've got the 2 side engines, 3 engines running. This is a 27-second burn. This will slow the first stage down. We'll then enter the atmosphere where the grid fins begin to work, and then we will fire the single center engine as we approach the drone ship.
Stage 1 entry burn shutdown.
Confirmation entry burn shutdown.
And meanwhile, that second stage is less than a minute away from cutoff.
Stage 2 in terminal guidance.
Shannon.
Copy, Shannon.
There's that call for Shannon.
Stage 1 is transonic.
Stage 1 decelerating as we prepare for entry burn, but our attention is right now looking at stage 2 as we get ready for shutdown.
Stage 1 landing burn. Dragon SpaceX. Nominal orbit insertion.
And the second stage has done its job. Our Crew 3 astronauts have been delivered into orbit.
Stage 1 landing leg deploy.
Landing leg deploy.
Endurance copies. We feel Kuko and Sile confirms we are in space.
Dragon SpaceX launch escape system is disarmed.
Stage 1 landing is confirmed.
And we've heard the call out. Stage 1 landing is confirmed.
Loss of signal Cape and acquisition of signal Newfoundland.
Some great call outs. That next milestone is spacecraft separation around 12 minutes into flight. The crew now coasting in low Earth orbit, still attached to that second stage. That second stage will separate, and Crew Dragon will be flying free.
Right now, that second stage, under control of its flight computer, is essentially going through a sequence to idle the second stage, make sure we're not pulsing any of the cold gas thrusters, the engine has been purged out. Essentially, anything that might cause motion of the second stage, we're making sure that all of that is eliminated so that when Dragon separates, it's got a very stable platform to move away from.
Expected loss of signal Wallops.
There we go.
Dragon separation confirmed.
Endurance copies. You say.
Dragon CE. Welcome to orbit. Hope you enjoyed the ride from F9. Dragon will take you from here. Safe travels.
The flight was the first for SpaceX's third Dragon crew capsule, which has been named Endurance. The other 2 capsules are called Endeavour and Resilience. A 4th Dragon crew capsule is on the production line. SpaceX says each Dragon crew capsule could be used up to 10 times. The new crew members will spend 6 months on station, returning to Earth in April 2022. Just before the launch, space station crew were forced to undertake another avoidance maneuver, this one to keep out of the way a piece of space junk from an old Chinese Fengying 1C satellite. It was simply the latest in a growing list of avoidance maneuvers needed to be carried out to avoid the growing amount of space junk in orbit. The Crew 3 launch came just 2 days after SpaceX's Crew 2 mission splashed down in the Gulf of Mexico off the coast of Pensacola, Florida.
All right, so we are continuing to track the return of Crew 2 and the astronauts back to planet Earth. We are just moments away from entering the deorbit sequence. Departure phase burn takes the Dragon out of the co-elliptic phasing that is really matching the International Space Station with both the perigee and apogee, and puts it on a course with that landing site, which is Pensacola, Florida. So we do have confirmation that all of the phasing burns, the departure burns that are necessary to line Dragon up for the deorbit sequence, which we're hearing is about to take place here momentarily. Dragon is in a good phase, a good position to get ready for this next sequence of very critical events.
And what that means is we have just one more burn left, the deorbit burn. Right. A couple of things need to happen, again, before we start this. In about 3 minutes, we'll begin to maneuver or slew the Dragon to the appropriate attitude in order to prep for claw separation and then trunk separation. After that, we'll slew back. The 4 forward bulkhead thrusters underneath the nose cone will fire for about 16.5 minutes. That will be what slows down Dragon and brings its altitude down enough to start to hit some of the atmosphere. And then from there, we'll start to re-enter the Earth's atmosphere, enter that blackout period for about 7 minutes where there's just plasma being built up around the exterior of Dragon. So we'll lose communications for about 7 minutes. After that, we'll regain communications. We have parachute deploys. We have two sets. First up is the drogue chutes that will take the Dragon capsule velocity from about 350 miles per hour to 120 miles an hour. From there, the main chutes will deploy, taking us from 120 miles an hour down to about 15 for a nice soft landing.
And confirm that the deorbit burn has started. Initial checks show that the dynamics of that burn are looking pretty good. This is going to be a long burn, 16 and a half minutes.
Again, Dragon is essentially flying itself, so all the crew has to do is stay strapped into their seats and keep tabs on things.
Copy all, good deorbit burn.
That is the news that we were looking for, Andy. A nominal deorbit burn. That means that that burn did its job. So the atmosphere is going to do a lot of the work here to slow the vehicle down. We're still close to orbital velocity. Of course, we're a little bit slower because we're dropping in altitude, and that is purposeful. The Dragon and the crew inside is now committed to enter the Earth's atmosphere and splash down off the coast of Pensacola, Florida. Dragon systems look good. The crew is monitoring every step of the way and checking in and saying that they are following closely. Everything's looking good on that end, and of course the weather is cooperating, which is super essential. Dragon is now beginning to flush nitrox into the cabin and continuing to top off Shane, Megan, Aki, and Tomas' suits with cool air. Again, this is what will allow the cabin temperature to remain comfortable while external temperatures reach 3,500 degrees Fahrenheit. That heat shield is pointed forward, leading the capsule to that landing site.
Dragon, nose cone secure for entry.
Endeavour copies, nose cone secured.
Endeavour, SpaceX for entry brief.
Go for entry brief.
Shane, things are looking really good. No deltas to timeline. Vehicle is nominal. We're tracking no issues for entry. Entry targeting is also nominal. Note that you may see the landing site slightly off in the world view. That is expected and nominal due to the entry purge, and entry guidance will clean that up, so that's nominal. There's no deltas to weather. The recovery fast boats have been launched, and they're awaiting arrival. I'll copy.
Great news all around. Thanks, Chris, and we copy all.
We copy. Thank you.
Further affirmation that everything continues to look good.
Hey, SpaceX, our tablets are secured. The trains are tightened. Visors are down.
We copy all. Thank you. Approximately 4 minutes, 30 seconds until anticipated comm blackout. We'll see you on the other side at 0326.
Copy 0326. Talk to you then.
Now in the blackout and entry period, we did hear some initial confirmation from the Dragon teams here. They're starting to see some drag, so we'll see the vehicle slow down here quite a bit.
SpaceX, comm check. And Dragon, we've got you. Expect automated parachute deployment, and we have you on visual.
Automated shoots.
Wonderful to hear from the crew on the other side of the blackout period. The WB-57 high-altitude aircraft providing thermal imaging.
Copy GPS, nominal altitude.
Again, nominal altitude for drogue deployment. That happens at about 18,000 feet.
Dragon, brace for drogue window.
We're braced.
Drogues deployed. Confirmation. That'll slow us down from 350 miles an hour to 120 miles an hour.
Dragon, visual on 2 healthy drogues. Descent rate nominal.
Copy, great news.
In about 30 seconds, the main chutes are going to come out. There are 4 of them, and they deploy at about 6,500 feet.
Drogue separation, main chute deploy, 4 healthy mains. Descent rate is nominal. That means we are expecting splashdown 3 minutes from now.
600 meters.
We copy 6.
400 meters.
300 meters.
200 meters, braced.
We copy 200 and bracing.
Standing by for confirmation of splashdown.
SpaceX sees splashdown and mains release.
Copy, we heard the main.
Endeavour, on behalf of SpaceX, welcome home to planet Earth.
Now, speaking of splashdown, it wasn't the most comfortable ride back to Earth for the 4 astronauts of the Crew 2 mission. It seems their Dragon capsule's toilet was broken, forcing them to rely on diapers or hold on for the 8-hour journey home. SpaceX says it is upgrading its cosmic commode for future missions after the orbiting outhouse aboard the Dragon capsules have proven to be less than a flushing success. In fact, during the recent Inspiration 4 space tourism flight in September, a hose became disconnected, allowing what's euphemistically being described as liquid to enter the spacecraft's ventilation system. And apparently there was a similar problem with the joint becoming unglued and disconnecting during the ascent phase of the Crew 2 mission earlier this year. Crew 2 spent a total of 199 days aboard the space station after launching back on April the 23rd. Before leaving the space station's vicinity, Crew 2 took their spacecraft for a fly around the orbiting outpost, the first time a SpaceX crew has undertaken this maneuver. It was standard practice back in the days of the space shuttle. SpaceX is one of two companies providing space station crew transport services to NASA under its commercial crew contract. The other, Boeing, is now 4 years behind schedule. Its CST-100 Starliner is yet to complete a successful unmanned orbital test flight to the space station. That'll now take place next year. In fact, the issue with Boeing and Starliner is now so bad, NASA's just caught on other companies interested in supplying crew transport services to the space station to make themselves known. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that smoking and drinking alcohol are likely to increase your risks of developing age-related macular degeneration, the leading cause of blindness in Australia. The findings, reported in the Journal of the American Medical Association, used a technique called Mendelian randomization, which uses genetics to allow scientists to look at whether one thing likely causes another, rather than them just being linked. It showed that it's likely that alcohol consumption does cause an increased risk of age-related macular degeneration. And it also showed that smoking plays a role in causing advanced age-related macular degeneration, but that quitting was likely to lower your risk. Okay, time for a correction. Last month we reported that the Stockholm International Peace Research Institute had estimated that China's nuclear weapons stockpile stood at around 350 atomic bombs. However, it seems that was a gross underestimation, with new intelligence reports by the Pentagon now showing Beijing will have at least doubled its nuclear stockpile to more than 700 deliverable atomic bombs by 2027 and over 1,000 by 2030. The new Pentagon report warns that the People's Liberation Army is expanding its nuclear arsenal much more quickly than anticipated. And Beijing's also building the infrastructure necessary to support this major expansion of its nuclear forces. Recent satellite images have shown construction of new nuclear missile silos across western China. The new developments come as China continues to expand its military forces for what Beijing describes as preparations for war. New studies have confirmed what many have long suspected. It seems that your cat is constantly tracking your location around the house. The findings, reported in the journal PLOS ONE, explains why kitty is suddenly surprised when their owner's voice appears to come from somewhere else. Scientists placed cats in a familiar room, then played their owner's voice, calling the cat's name from one of two speakers. But the authors then bamboozled the kitties by playing the sound on another speaker further away, and it seemed to surprise the furry friends. The authors say the findings show that cats seem to have a mental representation of where their owners were and were surprised when their owners appear to be somewhere else. I was shocked when I was at school and a girl called Rhonda stood up and proudly told our teacher, Mr. Owens, that Eve was created out of Adam's 13th rib. Now, at the time I smirked, but eventually I grew to forgive her naivety. After all, we were only in the 6th grade. Still, with all we know about science and evolution, even back in those days, it was a rude awakening for me as to how science illiterate some people really are. Now, many years later, I'm just as shocked to find out that almost half of all Americans still don't believe in evolution. With the details, here's Tim Mendham from Australian Skeptics.
The level of belief in evolution in America is very low compared to the rest of the world, quite frankly. The latest sort of study was looking at a whole range of surveys done over the last 20-odd years or so. Actually, it might have been even longer than that, 35, I think one thing mentioned. And they found out that in the last 10 years, the situation regarding belief in evolution has improved from 50% to 54%. So not a huge improvement. I'm not quite sure why. It might be more education of people in colleges and things, because that has picked up. But you would have thought actually in recent times that there has been a drop because of the increase in the fundamentalist movement and the sort of generally the areas where belief in evolution is low. So the latest figure was basically, I think it was 54% believe and about 30% don't, and about 15% don't know, something like that. It's a funny sort of area.
How does that compare to countries like Australia?
It's not a survey that's done all the time, but a 2013 survey, so getting on towards 9 years, found out that by the Academy of Science, by the way, an Ozpoll found that 80% of Australians believe in evolution, 70% believe it's currently occurring, so it's an ongoing process, and 10% believe evolution has occurred, but it's not actually occurring now. So, and then 12% were not sure, and only 9% stated they did not believe in evolution. So that's about a quarter of the percentage in the US. A similar UK poll done about 10 years ago found out that about 17% there believe that God created human beings in their present forms within the last 10,000 years. So that's pretty fundamental stuff. So that's double the number in Australia. So Australia has a pretty reasonable attitude towards belief in evolution. Certainly not the highest in the world by no means, but I mean it's better than the US, where really fundamentalist religious group have a major influence over people's belief in things like evolution. That implies also that there's a prominent belief in science generally, and that flows on into a lot of other areas, like as we're saying now, like vaccination and climate change and all that sort of stuff.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.